Most of the time we don't have quite as much stuff, but they kind of start out pretty big here. Right on top of this piece of paper, the properties of math, or operational properties, or just properties. The properties. Here's how the book shows you these properties. These are things that you do in math that you just say you can do without knowing why you can do it. For example, this one. I'll start with the property. You know that this is true, is it not? 3 plus 4 is the same as 4 plus 3, right? You can flip-flop those things. You can move them with addition. Now, just be aware that doesn't work with subtraction. You can't do that same thing with subtraction. You can't take 4 minus 3 and say that that's the same as 3 minus 4. It doesn't work. Okay, so there are some properties that hold true that you do that you don't really understand that you do. I'm gonna get rid of that, 'cause that's not part of it. What is this property called? Okay, and here's what you have to remember. In this property, you have moved numbers. They have changed places physically. This one went over there and that one went over there. Okay? When you move numbers like that, that's called the commutative property. Commutative. The word commute, if you've ever used it in a sentence, your parents might commute to work. That means they drive, they move, they go from here to there, they switch places. And then rather than just giving you one number example, the book gives you letters to stand for those. They say A plus B equals B plus A. Why do they use letters? Because you could put any number in for the letter A and it works. If you say A is 7 and B is 9, 7 plus 9 is the same as 9 plus 7, or you can flip-flop or whatever. That's the commutative property. The next property, people get confused with that. It looks like this. If you have 2 times 3 times 4, okay, and you do 3 times 4 first, what's the answer to that? What's 3 times 4? Times 2 is 24. That's the same thing as if you have 2 times 3 times 4, but you do this first, correct? What's 2 times 3? 6. And 6 times 4 is 24. Now people get that mixed up with the commutative property, but if you look at this, have the numbers move to different places. No, the numbers have all stayed the same. What happens is you've changed which ones you group together, or which ones the property is called the associative property. The associative property. It's like, what do you group together? If the groups change, I group this together the first time, and I group this together the second time, then it's the associative property. If the numbers have actually moved, then it's the commutative property. Okay? And again, that is true. These are true both for multiplication and addition, but they're not true for subtraction nor division. Okay? For example, if I have 16 divided by 8 divided by 2, and I do this first, is that going to be the same thing as if I have 16 divided by 8 divided by 2, and I do this one first? Notice the numbers are all the same, it's just what you associated together. What is 8 divided by 2? 16 divided by 4 is 4. What's this one? 16 divided by 8 is, what's 2 divided by 2? 1. There is no associative property with division. Associative property is either multiplication, addition, same thing with commutative property. So, and I'm going to get rid of that. I can tell you are mesmerized by 7th grade math already, even though you're not saying it. Alright, and then we have what's called the identity property. I'm just going to give you these because they're not real easy just to point out. The identity property is, getting the same thing that you started with. So if you're doing addition and I have 6, what do I add to 6 to get 6? Brianna?
0.
0. Yes. The identity property of addition is adding 0. Where it's a little different. What's the identity property of multiplication? What do you multiply 6 by to get 6? Bring it up. 1. So the identity property of addition is adding 0. The identity property of multiplication is multiplying by 1. And then we've got just one more that's called the 0 property of multiplication. Anybody think they know what the 0 property of multiplication is? It's going to be a hard one to think about. What happens anytime you multiply by 0? You've got 0. That's what it is. Multiplying by 0 gets 0. That's pretty much that whole property. And then, everybody got that? Let's write that down. My voice is really sore from this. Actually, turn to page 10. Oh, I'm sorry, 16. Page 16. Whilst you finish writing such things down, look at the practice set there, and I will see if you can come up with what property these are here. By the way, well, I guess not. I can't say that for sure. Look at letter A. 4 times 1 equals 4. What property that we have written down here is that? Look for the one that most resembles that. What are we doing there? Jade, shoot. Do you see any parentheses in that problem? Which one is, I mean, and you have to look for numbers changing places for this one, look for parentheses moving for this one, look for adding 0 here, look for multiplying by 0 there, look for multiplying by 0 there, and that'll probably give you the property. Grace Christ, it is the, and because they're different, you have to say the identity property of a multiplication. Because it is multiplication, it's not addition. How about letter B? 4 plus 5 equals 5 plus 4. 4 plus 5 equals 5 plus 4. Cameron? Exactly. Commutative property. Why? Because those two things, if you don't see parentheses, it can't be associative. Okay? If you don't see parentheses, it can't be associative. So those numbers moved, so it's the commutative property. Letter C, oh look, parentheses. 8 plus 6 plus 4 equals 8 plus 6 plus 4, where the parentheses have moved from the 8 plus 6 to the Lane-Kamaric, it is the associative property. Letter D, 0 times 5 equals 0. Okay.
The 0 property of multiplication.
0 property of multiplication. Letter E, what's the difference? Well, let's worry about that one later. Now look at letter G, because letter G is one we probably just need to chat about just a little bit here. 5, you are given this problem. 5 times 7 times 8, right? Is that what it is? And then it goes to 5 times 8 times 7. And then it goes to 5 times 8 times 7. And then it goes to 40 times 7. And then it goes to 280. Now, so this, ladies and gentlemen, look up here and bear with me. Let's see if this makes any sense to you. If I actually gave you this problem to do on paper, and you wanted to make it as easy as possible to do, actually even to be able to do it in your head, this is what you would do with it. You would say, what two numbers are most easy, are the first ones you'd want to multiply together? Because it doesn't matter with multiplication. Which two would you want to multiply together? 5 times 8. Why? Because you get a nice even 40 number, right? Now, you do that without thinking about the process that allows you to do that, and that's what this is. How do I get to be able to multiply the 5 times the 8 first? Well, it's through all these properties we just talked about. Okay, this first one, this was like if I did this. This was the given thing. That's what you have in the book, they tell you that's the given one. Now, this property here, if I went from this to this, what property did I use? Now you have to be careful here because you see parentheses. Okay, but the parentheses haven't changed. Actually what happened was, Grace, you moved the numbers, which means that what was what property? Yes. To get from here to here, I just flip-flop those numbers, and that's the commutative property. Okay, now to go from this step, notice the numbers are in the same order. What changed? The parentheses. To go from this step to this step, what property did I use? Kara? The associative property. And then this is, I just did the math. What did they put there? They just do the math part of it is. Okay, but you can do all this in your head because of those properties. You just don't know that you're doing them. And again, you couldn't do it if there was a subtraction problem there. You know, if I had 5 times 6 minus 7, I can't move this 5 over next to the 7 and do anything with that blah, blah, blah. Because once you do subtraction or division, none of those properties are true. So it's only with addition and multiplication. You know, you do it all the time when you do this. 6 plus 7, I'm sorry. Oh, 6 plus 3 plus 4 plus 7. If I asked you to do that problem, in your head you would tell me that problem automatically is 20. But that's only, you can only do that because of the properties that are involved there. And realistically, if somebody said prove why you can do that, you'd have to do this. 6 plus 3 plus 4 plus 7. That's your given, right? That's how I gave you the problem. Then what would you do? I wrote it down. 6. Sorry, 6 should go there. Then you could change this with this, right? You get 6 plus 4 plus 3 plus 7. What property did I use to do that? Yeah, I used the commutative property because I moved those things. Then, you know, you could put the parentheses in here, which works that way or whatever, and then you say that would be the associative property. That's exciting, isn't it? Do you not find that